Every city stands on a foundation. But what happens when that foundation is stolen from the ocean? Where once stood the humble huts of fishermen, today rise the ambitions to build towers of glass and steel. This is the story of the poor African families who lost their land, their ocean, and their identity, and of the engineers who declared, "We will hold back the ocean with modern technology." Finally, the mega project began. This is the story of EKO Atlantic, a city built on the ocean. It all began with erosion, when Lagos, Africa's largest coastal city, started losing its land to the Atlantic Ocean every year. According to estimates, the sea was eating away about 10 meters of land annually. That's roughly equal to the height of a 3-story building. In some years, the sinking reached up to 30 meters, nearly the height of a 10-story building. Since the time of Victoria Island, the coastline has moved back almost 2 kilometers, which is twice the height of the world's tallest building, Burj Khalifa. As we know, Victoria Island existed more than 100 years ago, but over time, the ocean swallowed it completely. So, was this disaster distant from the very beginning? In reality, it was caused by 2 major human mistakes. But before we understand those, we need to look at one small example that explains Victoria Island's natural problem. Imagine, when you go to the beach, you see waves repeatedly washing away the sand and then bringing it back again. Now, if an entire piece of land is built only on that same loose sand, what do you think will happen? Exactly. That land can never stay stable because it's basically a mix of water and sand. Victoria Island was just like that. It was originally a small sandbar, meaning the ocean had naturally gathered sand to form a temporary island, which slowly started disappearing over time. Mistake number 1, the harbor moles, 1908 to 1912. Around the early 1900s, the British wanted to turn Lagos Harbor into a major trading port. But at the mouth of the sea, where ships entered, strong waves and constantly shifting sand made navigation difficult. So they came up with an idea. If they built 2 long concrete walls on both sides, which engineers call moles or breakwaters, the waves could be controlled, and the port would become safe for ships. Mistake number 2, urbanization and sand mining. From the 1950s to the 1990s, Victoria Island developed rapidly. Hotels, ports, and oil offices were built everywhere. But for all that construction, uncontrolled sand mining took place. The areas that already had little sediment lost even more. As a result, the beaches lost their natural protective barrier. When strong tides hit, especially during the storms of the 1990s, Bar Beach was heavily washed away. According to local reports, dozens of buildings literally vanished into the sea. But the question is EKO Atlantic idea. A solution or a new problem? In between 1990s to year 2000, Bar Beach completely collapsed. The place that was once a weekend picnic spot was now just waves and broken walls. During every high tide, seawater reached the streets. Homes, hotels, and roads flooded again and again. Around year 2003, a private company called South Energy Nigeria Limited came up with a bold idea. If we can't stop the ocean, let's push it back and build a new modern city on the reclaimed land. That's where the idea of the EKO Atlantic City project was born. It was an $80 billion mega project. The reclaimed land was planned to cover 10 square kilometers. When seen from aerial drone footage, a golden island seemed to rise out of the sea. That was EKO Atlantic. The plan was to reclaim land from the ocean and build a luxury coastal city, filled with glass towers, private marinas, and smart infrastructure. A true Dubai of Africa, meant for the elite class. The city was designed to house 250,000 residents and provide jobs for another 150,000 people. It included high-rise commercial towers, a financial district, residential areas, marinas, and even an electric tram system. Engineers built an 8.5-kilometer-long Great Wall of Lagos, a massive sea defense barrier designed to resist Atlantic waves for 100 years. This wall was made from 100,000 concrete blocks, each weighing 5 tons. For the land reclamation, more than 90 million cubic meters of sand were dredged from the ocean and filled to create a stable base 2 meters above sea level. Dutch and Lebanese engineers played a major role, using satellite data and bathymetric surveys to monitor the process. Now, the whole world's eyes were on EKO Atlantic, the so-called Dubai of Africa. But one big question remained. Was EKO Atlantic a real solution, or just another problem in the making? Because the same mistake, the harbor moles, had already been made once before. The bigger the project, the bigger the controversy. When the reclamation of this project officially began late in the year 2000, coastal scientists and marine ecologists raised the first red flag. They warned that the Atlantic Ocean's natural tidal pattern and sediment flow were already unstable. If you build an 8-kilometer-long concrete wall and a whole reclaimed city in between, the ocean will try to change its path. And whenever nature changes its course, the damage always happens somewhere else. Then in 2009, the Marine Science Department of Lagos State University published a detailed survey. According to the report, in the area south of EKO Atlantic, near Lekki and Alpha Beach, erosion had increased by up to 20%. Satellite data and field measurements showed that the wave patterns had changed, and the new sand barrier was redirecting wave energy. And weather result, the coastlines of nearby fishing villages were retreating by 5 to 10 meters every year. 2 small communities, Karamo and Okun Alpha, lost part of their land to the sea. One local fisherman's quote became famous. "They stopped the sea from coming to them, but sent it toward us." Environmental Rights Action, ERA, and several local NGOs also questioned the project's social impact. They said EKO Atlantic had turned into a luxury enclave, built for billion-dollar investors and foreign corporations, while the local fishing families who had lived near the coast for generations were displaced without proper compensation. One side has glass and steel towers, while the other has the tents of people whose homes were swallowed by the sea. In an official statement, ERA wrote, "EKO Atlantic is turning an ecological disaster into a business opportunity." Even the international community gave mixed reactions. Dr. Robin Daniels from the UK Coastal Research Centre wrote in his paper, "Land reclamation itself isn't wrong, but doing it in a region where sea levels are rising faster than the global average, that's like building a sandcastle while the tide is coming in." Despite all this, Nigerian authorities claimed their design was resilient and future-ready, and that EKO Atlantic would actually become the solution to Lagos's flooding problem, not a new threat. Many people believe that this mega project, which started in 2009, was completed by 2020. But the truth is, that was just an expectation. As of 2025, only about 35% of the area has been developed. Only a few high-rise towers and main roads are finished, while the rest of the zones are still under construction. Another common misunderstanding was that the project is flood-proof, but engineers clarified that there's a difference between flood-resistant and flood-proof. The design can delay the impact of storm surges and rising sea levels, but it cannot stop them completely. Example: flood-resistant equals can handle some effect of rain or flooding, but not completely protected. For example, a wall that gets slowly damaged by water but doesn't collapse. Flood-proof equals completely unaffected by flooding. Water cannot enter at all. For example, an airtight glass tank where no water can get in. The most important questions now are, is the reclaimed land stable in the long run? As of 2025, phases 2 and 3 of EKO Atlantic are still under construction. Experts say that if sustainable drainage systems and coastal greenbelts are added within the next 10 years, the project could become a model for climate adaptation. But if maintenance and monitoring are neglected, then after 2040, the area could face regular seawater intrusion. So the key question remains, can this reclaimed land stay stable in the long term? IPCC estimates that if sea levels rise by 1 meter by 2100, EKO Atlantic's safety will be at risk. UN Habitat's 2024 report also states that West African coastlines could retreat by up to 50 meters by 2100. If the city fails in long-term flood protection, an $80 billion investment could literally sink into the sea. These questions still haven't been officially answered, and that's why EKO Atlantic remains at the center of engineering and environmental debates. The future is still being written. When it comes to land reclamation, projects like EKO Atlantic aren't new to the world. Many similar projects have already been completed, and many more are still ongoing. For example, Dubai built Palm Jumeirah and the World Islands, while Singapore expanded its coastline by nearly 25%. The difference, however, was that those countries continued long-term monitoring and soil compaction testing for decades after reclamation. In EKO Atlantic's case, monitoring was very limited. After 2015, satellite imagery showed some signs of uneven subsidence, ground sinking. This doesn't mean the city is unsafe, but it does highlight an engineering challenge. Geotechnical mats, synthetic fabric sheets made of strong plastic or fiber, are used beneath the surface to hold sand together and prevent erosion. Vibrocompaction, or vibroflotation, is a ground improvement method where a heavy vibrating probe is inserted into the soil to shake and tighten sand particles, strengthening the ground and reducing the risk of sinking. By comparison, Palm Jumeirah had both geotechnical mats and vibrocompaction layers beneath every reclaimed section, while unfortunately, EKO Atlantic didn't apply these methods at the same large scale. EKO Atlantic's design and planning were inspired by New York's financial district, with high-rise buildings, business towers, wide boulevards, waterfronts, and modern utilities. The goal was to create a futuristic financial hub, but so far, only about 10% of the high-rise structures are operational, which you can even verify on Google Maps. The projected population was around 250,000, but the current occupancy is only about 30,000. EKO Atlantic stands as a testament to human ambition and engineering excellence. But ambition alone is not enough. Careful planning, environmental integration, and consistent maintenance are essential for long-term success. With these measures, reclaimed land can thrive and even set a benchmark for future coastal developments. EKO Atlantic's engineers once said, "We are not fighting the ocean. We are learning to live beside it." This line is both a reality check and a message of hope. Humanity has always tied its future to the oceans. Ports, harbors, and coastal cities have been the backbone of civilization. But if development loses balance, then progress itself can turn into collapse. EKO Atlantic is an engineering marvel. It reminds us of one simple truth. Beneath every piece of concrete, the earth has its own reaction. What do you think? Can humans really win land from the ocean without harming the environment? Let us know your thoughts in the comment box below. Share your thoughts in the comments, and subscribe for more real-world stories where engineering and the environment intersect.